Hello students, you have to be clear with all the theory that we have discussed for this chapter, classification of elements and periodicity in properties. So the concepts that we discussed were the arrangement of elements in the modern periodic table, and then we did see the IUPAC nomenclature. Then we saw like four different periodic trends. They were atomic radius, electron gain enthalpy, and then ionization enthalpy, electronegativity. You have to be clear with all those four concepts that I've taught you. You should also know the way it's going to arrange across the period and down the group. And then finally, we saw those chemical reactivity, right? So in that stuff, we did see the acidic strength and then the basic strength. Acidic strength is something that we saw. Basic strength is going to be the other way around, right? So for we did see for oxy acids, and then for the acid anhydrates or acidic oxides, and then finally for the hydrates, right? You have to be clear with all those stuff. Got it? So those were something that we saw in the theory part. If you are thorough with all the stuff that I've told you, same way you should have memorized certain thing that I've told you. Only if you would be able to solve these sums easily. Got it? Sums will be super easy. Just by looking at the sum, you'll be able to mark the answer. Got it? So together from 2000 to 2023, we have got around 36 sums. That's it. So for an examination, you can hope to get one question. If we are lucky, we can get like two questions. That's it. And by the way, this is an important chapter. Anyway, you should have learned this chapter. So this will be the foundation for the upcoming chapter. So you should have learned this one. That too, this chapter is an easy chapter. Just a little bit of memorization by hearting stuff is there. You have to do those things, and the concept wouldn't be more tricky to remember, right? So that's going to be easy. Got it? So we will do those sums in two sessions. In the first session, which means in this session I'll do around like 18 19 sums. Okay, it will take around like 40 45 minutes. That's it, right? Yeah, it's going to be shorter session. And in the next session we will do the rest all other sum. That too will come around like 18 19 sums. That's it, right? Fine. So you have to be clear with all the theory that we have discussed. Let's jump into the first question. In this question, you have got identify the incorrect match. So I just need to get the incorrect match the following for this question. See, I've told you already while doing the theory, you should have memorized those elements 101 to 118. Only if you have memorized all those elements, you'll be able to get the correct answer over here. What they're asking us to find is the incorrect match. I just know the answer straight. I will put it. Anyway, the part that needs to be done by you is you should have memorized all those 18 elements. If only you know these names and its number, you'll be able to get the answer over here. 1 2 3 A B C, these three answers are going to be right. Got it? If you had memorized, you would be able to match this one. Fourth one, D is the wrong over here, right? So it's gonna be EM. So it's like 1 and EM. That's gonna match with Rongenium. But in this situation, they have matched with Darmstadtium. Okay, so Darmstadtium. For the Darmstadtium, that's gonna be 110. They have matched with 111. So that's the incorrect matching over here. Got it? Therefore, the answer over here is option 4. Fine. So to solve this sum, only stuff that is left is you should have memorized all those 118 elements. Only if you know from 111 to 118, you would be able to solve this question, or else obviously you wouldn't be able to solve this question, right? So you should be clear with this first one, simple one. Let's move to the next one. Next question is also simple one based on the atomic number. You have got the number of protons and neutrons, electrons in lutetium, okay, Lu respectively, or got it. So I just need to get the number of protons, electrons, and neutrons in this element Lu. They have given you the atomic number and then the mass number. So to get the protons, it's gonna be easy. Atomic number and the proton are just the same thing, right? So the count of atomic number and then the proton has to be same. Therefore, 71 should match. So 71, you have got like two 71s over there. Okay, either it could be option 1 or it could be option 3. Here, let me verify with the next one, which is going to be the neutrons. So to get the neutrons, what should I do? That's going to be the mass number subtracted from the atomic number. That should give you the neutrons. And then for the electrons, if it was a neutral atom, obviously they haven't given any sign over there, therefore it should be a neutral atom. Number of protons and electrons has to be same, therefore 71 71. See, if you look at the option 3, that's wrong, right? 71 104, that's not possible. Therefore, option 1 has to be my answer because 175 minus 71, that's obviously going to be 104, right? Therefore, the answer over here is option 1. Fine, simple sum. I've told you, right? Just by looking at the question, we'll be able to get the answer. Fine, so these are like super easy sums that you get in the chemistry, but you don't get such a kind of question in physics. But with the case of chemistry, that's you get those easy sums. Fine, it has to be clear. Let's move on to the next one. In this question, you have to get the electronic configuration. Let me read the question. The element Z equals 114. So they have given you the atomic number, which is equal to 114, has been discovered recently. Okay. It will belong to which of the following family or group and electronic configuration. So I just need to get it, to which family will it belong to, and then same way I just need to get like which family I mean I just need to get the electronic configuration, then I have to find which family does it belong to, the group, either it could be carbon, oxygen, nitrogen family, whatever it is. First let me get the electronic configuration. Once I get the electronic configuration, these stuff will just automatically flow. Got it? So to get the electronic configuration, first I just need to know how many electrons will be filled in the radon. Okay, so this is obviously noble gas. Okay, so to get this one, let me figure it out. So hydrogen, helium. With the case of helium, you will have like two electrons filled, right? Then after helium, you would have got like neon. So helium, neon, argon, krypton, right? So helium, it's going to be 2, helium, neon, argon, that's going to be one more 8, and then krypton, that's like 1d shell get will get into it, so that's going to be 18. Okay, so helium, neon, argon, krypton, then you would have got like xenon, that's going to be 18. Then you would have got like radon. So with the case of radon, you would have got 32, isn't it? Because that is going to be 18, and then you would have got like 14 added to it. So when you add like 18 plus 14, that will give you 32. Yeah, right? Yeah, that's going to be 32. So this will give me the electronic configuration for the radar. Okay, if you had known by heart, that wouldn't be a problem, but if you have to figure this one out, just remember that periodic table that I've taught you. So with the case of helium, that's going to be 2. Then you would have got only S and P. So that's going to be 8 and 8, the next two periods. Then the next two periods would have got like D shells into it. So one more 10 electrons will get added. So 18, 18. Then after that, you would have got like D plus F. Therefore, you would have got like 10. Again, 114 to it. That will give you like 32. So this is the total number of electrons that would have been present in the radon. So let me add all those stuff. Let me add all those stuff and then you'll get it. So here, if I have to add this one, you will get like 2, 8 is going to be 10, 10 plus 8 is going to be 18. After 18, you would have got like one more 8 to it. So 18 plus, yeah, 18 plus 8, isn't it? So that's going to be 30, 26, right? So that's going to be 26. After 26, one more 8 to it, that's going to be 34. After 34, you would have got like 1, 2. So that's 36, right? Here you would have got 3. So that's going to be 6, 86. Fine. So the number of electrons that you would have got in the radon will be like 86. Now I have got this one. So they have given you the atomic number to be like 114. So if I subtract 114 minus 86, that's it. That stuff is done. Leftover electron has to be filled in the existing subshell, existing upcoming subshell. Okay. So here to put that one, I just need to know the difference. So the difference would be like 114 minus 86. Got it? That's gonna be 14. Yeah. 14 minus 6, that will give you 8. You would have got like 28. So I just need to fill the 28 electrons, the upcoming subshells. So if I have to fill those 28 electrons, so that's gonna be, see, do not want to worry about this F and the principal quantum number for the F, D, S and P. That has been given straight away. That's going to be the 7th period. So you would have got like 7S, 7P. It's matching perfectly. Then you would have got like 6 because one number less than that will match with the D subshell. Therefore, it's going to be 6. With the case of F, that's going to be 5, right? So here in this situation, it's like perfectly matching for all the options. Therefore, do not want to worry about the principal quantum number. Only stuff that I need to worry over here is how is it gonna fill. Got it? First two electrons will get filled in the, it will get filled in the 7s2. Then you would have got like 5f14, isn't it? F will get filled. Then you would have got like D. Finally, you would have got like P, right? So if you look over here, it should be obvious. All the 14 is filled in the F. Same way, all the 10 is filled in the D. Same way, all the 2 is filled in the S. Only stuff that is missing over here is with the P subshell. Okay. Yeah, that is when you'll get this carbon family, oxygen, nitrogen, and then the halogen family, right? So I just need to get the count of 28. That's what I'm worried over here. Let me check with the first option. You would have got like 10 plus 14. That's going to give you 24. 24 plus 2 is going to be 26. 26 plus 2 is going to be 28. The first option in itself is matched. So here, that's the answer is going to be the first option. Therefore, it has to be in the carbon family, right? So obviously, it has to be in the first option because rest all other options are going to be different, right? So the answer over here is option 1. It has to be clear. Simple sum. Yeah. If only you know the arrangement of electrons in the periodic table, you will be able to get this one, right? Just get the number of electrons for the radon, then just start filling with the upcoming subshells, right? Once you start doing that one, only the last subshell with P is missing over here. Therefore, just to get the total count of 28, I've just matched over here. Once that stuff got matched, that will be my answer. That's it. It has to be clear, no doubt should be there. Let's move to the next question. This question is also simple, straightforward one. Let me read the question. Be2 plus is isoelectronic with which of the following ions? Right? So Be2 plus. Got it? So in the situation, 2 electrons has been removed. Let me get the atomic number. Hydrogen, helium, lithium, beryllium. So that should be like 4 electrons. 1s will be filled. Same way 2s will be filled. Here I just removed 2 electrons from the valence shell. Okay, so it is just left with 2 electrons. I should match it with the options that I've given over here. H plus, no electrons is there, so that wouldn't be my answer. Then Li plus, obviously that has to be my answer because lithium had 3 electrons, one was removed. Okay, then it should have like 2 electrons into it. Therefore, the answer over here is option 2, right? Simple sum. Let's move to the next one. This question is also based on electronic configuration. Let me read the question. You'll get it straight away. If n equals 6, the correct sequence for filling up electrons will be, right? So they've given you the n equals 6. I just need to get the electronic configuration for the lost valence shell, okay? So if n was equal to 6, then it has to be like ns or 6s, okay? Then what should it be? For the f, it has to be, obviously you will have f subshell over there because the last one is going to be the 7th one before 7th period. Before that, that's going to be like 6th one, okay? So here they have given you clearly that's going to be n equals 6. So it will be like 2 number less than that of the n. Therefore, that's going to be n minus 2f. Same way with the case of d subshell, that's going to be one number less, which will give you n minus 1d. And then you would have got like np. First one in itself is correct. Okay, this in this pattern is going to fill, right? First it will fill the S subshell, then it will fill the F, then it will fill the D, finally it's gonna fill the P, right? If you look over here, after N, you have got like D. That's not how it's gonna fill. Okay, I'll have to match it with the correct sequence over there. Okay, so it's gonna fill with S, then it will fill the F, then it will fill the D, finally it's gonna fill the P. Okay, they're asking us in which pattern it's gonna fill. Got it? Even for the other options, you still get the same count, but what they have did is they have just rearranged or shuffled those subshells. They are asking us the order in which the electron is going to fill, which means they are asking you to get the half-bow principle, right? So the answer here is option one. Simple sum, right? You shouldn't have any doubt on this question. It has to be clear. Let's move to the next one. This question is also a simple one. Let me read the question. An atom has electronic configuration. They've given you the configuration 1s2, 2s2, 2p6, 3s2, 3p6, okay, 3d3, 4s2. So they've given you the electronic configuration over here. If you just look, get the greater number, that's going to be n equals 4. So this is actually the fourth period, okay. It's going to have d subshell into it. Yeah, you will place it in. So in which group I'll be able to place this element? It's going to be obvious because yeah, up to this it's going to be some stable configuration. Let us leave that those stuff. Then it will start filling in the fourth period, which will be like 4s2. Yeah, 4s2. If it gets filled, that's going to be the second group, right? Here the d shell is also filled, therefore you would have got like 4s1, 4s2. Then you would have got like 3d1, 3d2, 3d3. So you would have got like 3 and then 2. So the group is going to be 4. So that's going to be, I mean, 5. So the group over here is the fifth group. Got it? Just I mean, get the idea of the periodic table, you'll be able to get the group. Got it? So here the group is going to be the fifth group, because here it's going to be 3d3. If you just look at the 4s2 and mark it, you'll end up marking the second group. Be careful. That is this one, 3d3. Fine. So the answer over here is option 1. It should be clear. Simple one. Let's move to the next one. In this question, I need to get the isoelectronic species. Let me read the question. Simple one. Isoelectronic species are. So I just need to get, out of all the combinations that they have given over here, which one has the same number of electrons count. Okay. If I just count all the number of electrons in both the atoms of a molecule, it should end up getting the same number of electrons count. Okay. So that's what I just need to get over here. So if you look at the option, so you have got the same kind of molecule, only stuff is they have just changed the anion and cation. Okay, so that's what they have done over here. Here it is like CO, here it is like CO minus, CO plus and CO, right? If you know the electron count of the main molecule, then just add 1. If it is like Cn negative, just subtract 2 or 1 if it is in the positive oxidation state. Okay, so that's what you need to figure it out over here. First let me take the first option and I'll do it. Same way, if first option didn't work out, then let me verify it for the rest 3 options. Got it? Once you get the first one, then obviously verifying other stuff will become easy. Carbon monoxide. Okay, so that's gonna be CO. With the case of carbon, you would have got hydrogen, helium, lithium, beryllium, boron, carbon, 6, right? So you would have got like 6 electrons. Same way, with the case of oxygen, you would have got like 8 electrons. So together, that's going to get you 14. Yeah, 6 plus 8 is going to be 14. Therefore, CO gives you 14. If it was CO minus, that should have been 15. That's it, finished. Add one extra electron. If it is CO plus, just subtract one extra electron. That's gonna give you like 14, 13 over there. Fine. Then let me do it for the Cn minus. Cn minus. Okay. So for the Cn minus, what will you get? For the carbon, that's gonna get you same way, it's gonna get you 6. And then for the nitrogen, that's gonna give you 7. Yeah, one number less than that of the oxygen. So 6 plus 7 will give you 13. Okay. Adding one more extra electron to it, because Cn negative, so you have to put one more extra electron to it, so that will give you a total count of 14. So even for Cn minus, you have got like 14. Oh, it's working out really well. Then let me do it for the No plus. Okay, nitrogen is going to get you 7, and then for the oxygen it's going to be 8. So together that will give you 15. Just remove one electron from it as it is positive. Same way here also it will work out, which is going to get you 14. It should be clear. Then with the case of C2, 2 minus, let me verify it. If I do verify that one, that's going to be, yeah, same way. It's like 6 plus 6, 12. 12 plus 2, because 2 minus will give you 14. So here all the molecule has 14 electrons into it. Therefore, the answer over here is option 1. Simple, straight away, easy question. So the answer over here is option 1. Fine. You shouldn't have any doubt on this question. It has to be clear. Let's move on to the next one. This question is going to be the same exact thing that you have already seen in the theory. If you're comfortable with the theory, you should get the answer straight away for this question. The question is based on ionization enthalpy. Let me read the question. For the second period elements, the correct increasing order of first ionization enthalpy is. So here I just need to get the increasing order for the ionization enthalpy for the second period, right? So obviously the first one has to be the lithium. I just know it's gonna be increasing order. So across the period, it's gonna increase. Fine. So with the case of lithium, it will be easy to remove that electron when compared to rest element in that period. So boron and beryllium, these two stuff will get flipped. lithium, beryllium, boron. That's what we were expecting, but we'll get like boron, beryllium because beryllium has half, I mean, like fully filled s orbital. Therefore, that will be more stable. It will be hard for me to remove. Therefore, these two stuff will get interchanged: lithium, boron, beryllium, then carbon, then oxygen, nitrogen, oxygen, isn't it? But here it should get flipped. Therefore, you will get like oxygen, nitrogen. The reason is because here you have had partly filled P subshell. So partially filled P subshell will be preferred. Therefore, it will be hard to remove that electron from the nitrogen. Therefore, oxygen and nitrogen, it will switch places. Then fluorine, neon. So neon is going to be extremely stable. Therefore, it will be extremely hard to remove that electron, isn't it? So the answer over here is option 3, right? If you're comfortable with the theory, this should get you the answer straight away. You shouldn't have any doubt on this question. Let's move to the next one. Next question is based on the nature of oxides. I'll have to do the match the following, right? It's gonna be easy. Match the oxide given in column 1 with the property given in column 2. Okay, so they've given you some oxides and I just need to match it with the neutral, basic, acidic, and amphoteric, right? If you're comfortable with the table that I've told you to memorize, this should get you the answer straight away. So here, if you just look over here, you'd have got like Na2O. Got it? So sodium, that's towards the left, so that has to be basic, right? So sodium has to match with the basic. Then you have got like Al2O3. Obviously we know that's going to be amphoteric, that's going to be in between. Got it? So Al2O3 is in between, so that's like amphoteric. Then you have got like N2O. I've told you like N2O, NO, MnO2. You have to memorize this one. All those stuff is going to be like neutral. Therefore, N2O is going to be neutral. It will neither be basic nor be acidic. And finally, you have got like Cl2O7. That's going to be acidic. Okay, so that's how it's going to be. I just have to match this one. Comfortable with the theory? Straight away you'll get the answer. That's it. So Na2O is going to be basic, right? So one has to match with B, one has to match with B. You have got like two options. Then 2 has to match with D. Yeah, 2 matching with D is going to be option 4. Then 3 will match with A, and then the 4 will match with C, right? Option 4 is going to be my answer, right? So the answer over here is option 4. Simple one. Comfortable with the theory, have memorized all those stuff that I've told you in the theory. This thing will get you the answer straight away. It has to be clear. Let's move to the next one. This one is also a simple one. Yeah, straight away question. Let me read it. Which of the following oxides is most acidic in nature? So I just need to get the acidic out of all the options that they have given over here. See, if you look at those options, all these oxides are actually an basic oxide except this beryllium oxide, which is going to be the amphoteric, right? But what they're asking us to find over here is which one is the most acidic out of all these basic oxide, and one is going to be the amphoteric one. Which one is going to be the more acidic? That's what I need to get. Fine. Anyway, I've told you straight away. Rest all other things are basic oxide. This is the only stuff that can behave both as acid and base. Therefore, beryllium oxide has to be my answer. But here, if you have to get it logically, how will I do is we know down the group the acidic nature decreases, right? So something that is at the top is going to be acidic. As you move down the group, acidic nature decreases. Therefore, beryllium will be at the top of that group. Okay. So you would have got like beryllium, magnesium, calcium, strontium, barium. Therefore, beryllium oxide will be the most acidic for this question, right? You should be clear with this question. Let's move to the next one. Next question is based on the order. Let me read the question. In which of the following options the order of arrangement does not agree? So they're asking us to find the incorrect arrangement with the variation of property indicated against it, right? So first, let me verify all those stuff and I'll have to get the incorrect arrangement. Fine. So let me verify it for the first option. So here, what they're asking us to find is increasing electron gain enthalpy. So here, I just need to get the electron gain enthalpy order for the halogens, right? So this is going to be for the halogens. So if you look at the halogens, as you move down the group, it has to decrease, right? As you move across the period, it has to increase. As you move down the group, this one has to decrease. Therefore, the order will be such that fluorine, chlorine, bromine, iodine, isn't it? See, in the situation, I've told you in the theory itself, chlorine and bromine will switch places. So you would have got like chlorine and then the fluorine. As you move down the group, this is going to decrease. Therefore, you would have got something like this. Yeah. As it's going to decrease, you would have got like greater than symbol, right? So that's going to be greater than arrow. This one, this one, this one, right? So with the case of chlorine, more energy would have been released. Then you would have got like fluorine, bromine, and then the iodine, right? So this is how it has to be. So if you look over there, they have just written it other way around. So iodine less than the bromine, yeah, that's matching. Bromine less than the fluorine, then you should have got the chlorine. Yeah, here this is like other way around. Therefore, option one is actually the wrong one, which has to be my answer, right? So now I have got the option one, which is going to be my answer. Let me verify all the rest three options. Got it? So the answer has been marked. Lithium, sodium, potassium, rubidium. Here I have to get the metallic radius. Got it? So whatever it is, atomic radius, metallic radius, both are same in the situation. As you move down the group, it has to increase. Lithium is less, sodium is bigger, then comes the potassium, then comes the rubidium. It's like perfect, that's right. That shouldn't be my answer. Then you have got like Al3 plus, Mg2 plus, and then the Na plus F minus, increasing ionic size. Yeah, that's right. More the size of more the cation is gonna have less size because it's going to get attracted too much, or more the oxidation state less the size. So Al3 plus will be lesser, then comes the Mg2 plus, Na plus, and F minus. By the way, these are like the next element, right? Fluorine, neon, sodium, magnesium, aluminum. Therefore it is isoelectronic, and also it's like properly arranged. Okay, so Al3 plus, which is less than Mg2 plus, sodium, and then the fluorine. Okay, it has to be clear. Option 3 is right, therefore that 2 shouldn't be my answer. Let me tell you for the fourth one, and then we'll move on to the next question. Here what they're asking us to find is the first ionization enthalpy, right? Boron, that's fine. Then after boron, it has to increase. Okay, the order is fine. So boron, then you would have got like carbon, then it should be like oxygen, nitrogen, right? So boron, which should have the lowest ionization enthalpy. So ionization enthalpy also increases across the period. So it should have been like boron, carbon, then you should have got like oxygen, then should come the nitrogen, right? Here these two stuff didn't switch places. Therefore, this also can be my answer. Fine. So option 4 can also be the answer over here. But in this question, two answers are right. Therefore, you have to mark only one of the options which is right. You shouldn't mark option 2 or option 3. If you end up marking these two options, they'll give you like -1. So be careful. You shouldn't mark that option. What you should do is you should either you can either mark option 1 or you can either mark option 4, but never mark both those options, because in NEET marking two option is not allowed. Just get the answer that is right. That's it, finished, right? Do not want to worry about the other answer which is also right. You can mark option 1 or you can mark option 4. Should not mark both those options. Got it? Fine. It has to be clear. Let's move to the next question. This question is statement based question. It is also easy. Let me read the question. The formation of the oxide ion O2 minus from the oxygen atom requires first an exothermic, okay, and then an endothermic step as shown. Got it? So from the oxygen O atom to get this O2 minus ion, I'm gonna what I'm gonna do is I'm just gonna add extra electron to it. So that's gonna be electron gain. Fine. So with respect to the first electron that I'm gonna add, that's obviously gonna be negative, which means energy will get released. Fine. So O, when I'm gonna add one electron to it, when it gains one electron, it obviously releases energy, -141 kilojoule per mole. Then for the next step, when I'm gonna add the second electron to it, so here it becomes O2 minus, but in this situation, I'm the one who is going to give the energy to it, which is like plus 780 kilojoule. It has released -141, but I gave like but I gave like 780 kilojoule when I was about to add the second electron into that O minus ion, right? So here together, if you just sum these two values, obviously I was the one who gave the energy to get to this O2 minus, fine. So what they're asking us to find is, thus process of formation of O2 minus in gas phase is unfavorable, even though O2 minus is isoelectronic with neon. So even though O2 minus gets the stable configuration, still this isn't favorable. It is due to the fact. So what is the reason? That's what I need to get. So I'll have to read the options and just get the correct matching option for the equation that they have given in the question. Okay, let me read the first option. That's going to be O minus ion has comparatively smaller size than the oxygen atom. That is inappropriate, and by the way, that is false, because O minus is going to have larger size when compared to that of the oxygen atom. So that one is wrong. Oxygen is more electronegative. Yeah, oxygen is electronegative. If it was like electronegative, we should have absorbed that electron. By the way, that doesn't make sense because this is actually a separate atom over there. So that too doesn't make sense. So oxygen is more electronegative, doesn't make any sense over here. Addition of electron in oxygen results in larger size of the ion. Okay, so if you're going to add electron, that's going to increase its size. Fine, the statement is right, but that doesn't seems to be a good argument for the question. Let me read the fourth option. That should have been my answer anyways. So here it is. Electron repulsion outweighs the stability gained by achieving noble gas configuration. Yeah, that does make sense, right? So here, even though it has achieved noble gas configuration, that's not favored or preferred because putting one more extra electron, what has happened over there is the electron repulsion in the valence electrons is going to outweigh, which means the electron repulsion produced by those valence electron is going to be more when I need to put one extra electron into it, right? So here electron repulsion is greater than the stability gained by achieving noble gas configuration. Fine. So the same argument that we did while discussing the theory. So here this one isn't preferred because electron repulsion has become more when compared to that of the stable configuration. Fine. So the answer over here is option 4. It has to be clear, right? Straight away statement based question. No doubt should be there. Let's move to the next one. This question is based on the ionic radii. Let me read the question. Which of the following orders of ionic radii is correctly represented? So I just have to get the correct options over here. Fine. Let me check the first one. H minus has the greater ionic radii. That's an anion. Then comes the cation and then the neutral atom. That's not how it's going to be. It has to be like H minus, then you should have the neutral atom, then you should have got the H plus. So first one is not the answer. Okay. Let me check the second option. Na plus, F minus, O2 minus. Yeah, it's completely other way around. So O2 minus should have had the greater ionic radii. So that one is also wrong. Radius. Then with the case of F minus, O2 minus, Na plus, O2 minus should be at the first, right? Because that should have had the greater ionic radius. So that this one is also wrong. So let me verify it with the fourth option. If you look at the fourth option, it's going to be Al3 plus, Mg2 plus, and then N3 minus. Oh, this one is also wrong because N3 minus should come first. Yeah, then you should have got like Mg2 plus and then the Al3 plus. So this one is also wrong. Fine. So this stuff is also wrong. So if you look at these four options, see all the four options over here is wrong. If you get such a kind of question, what you should do is you should leave all the four options. So if you just leave this question without marking any option, they'll give you 4 mark. If you end up marking any one of the options, then they'll just give you -1, which means none of the options were right, but you ended up marking one of the options. Then obviously you do not know that question, therefore they'll reward you with -1 mark. But if you didn't mark any of the question, if the question was unattended, they'll give you 4 marks. Okay. So if you get such a type of question, what you should do is you just leave the question, move on to the next question. See, very rare you get such a kind of question. You can't expect this kind of question in the examination. That's not possible. Very rare. For the lucky students, they might get such a kind of question. Fine. If they don't know the question, they'll be much more lucky because they'll end up getting that 4 marks, right? Fine. This question has to be clear. Let's move to the next one. This question is also based on electron gain enthalpy. Let me read the question. Which one of the following arrangements represents the correct order of least negative to most negative electron gain enthalpy for carbon, calcium, aluminum, fluorine, oxygen? Okay, so they have randomly given some elements and they are asking us to find the order. So here obviously you shouldn't consider the negative sign because they have given you clearly least negative to more negative. Okay, so it has to be the increasing energy level. Okay, so we just know across the period it increases and down the group it decreases for the electron gain enthalpy, right? So first let me fix those elements with respect to the periodic table. Yeah, you would have got something like this. Yeah, fluorine will be towards the extreme right, so that's going to be the fluorine. So before fluorine you would have got the oxygen. Okay, then yeah, then you would have got the aluminum, isn't it? Yes, you have got the aluminum, sodium, magnesium, aluminum, right? So that it's gonna be the aluminum. Then you have got the carbon. So carbon, boron, carbon. Okay. Then finally you should have got the calcium. So sodium, magnesium, and then potassium, calcium. So calcium should be over here, right? So just get the arrangement based on the periodic table. Fine. So once you get this arrangement, I'll be able to get the electron gain enthalpy. So in this order, I wouldn't get any flipping because with the case of halogen, this fluorine comes next to the chlorine, but you do not have chlorine over there. Oxygen comes at the last, but here you do not have any other elements, sulfur, selenium, those kind of elements. Therefore, just get this arrangement straight, you'll get the answer. Across the period, it's gonna increase, and down the group it's gonna decrease. Okay, so if you look across the period, which one is the first? That's gonna be the fluorine. So fluorine should have the more amount of electron gain enthalpy. So fluorine will come last. Okay, before that you should have got like oxygen, so only one option is left, so option 4 should be my answer. Then before that you should have got like carbon. Then before that one it should be like boron. So down the boron you would have got like aluminum, so that should be less than that of the boron. Okay, then you have got the carbon, okay, which is like on the right side, which is on the left side, therefore that should have had the least electron gain enthalpy. So it has to start with the carbon, and then it increases to aluminum. It has to start with calcium, aluminum, carbon, oxygen, fluorine. Okay, so that's how the order has to be. Option 4 is the answer over here. Calcium, aluminum, carbon, oxygen, fluorine. Fine. It has to be clear. No doubt should be there. Fine. Let's move on to the next one. Next question is, in which of the following arrangements the given sequence is not strictly according to the property indicated against it? So I have to find the incorrect arrangement. First, let me verify the first one. HF, HCl, HB or HI. So when you have high rates, it doesn't matter across the period, down the group. It's just gonna increase. Okay. So here, increasing acidic strength. Yeah, that's correctly matched. Therefore, option 1 shouldn't be my answer. Yeah, it's like pKa value. I'll just explain at the end. So then let us see the option 3. So when you look at the option 3, same way here also you have got like high rates H3, 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 H3. So here also it doesn't matter across the period or down the group. It's gonna increase, right? So NH3, PH3, AS, arsenic, antimony. So here also it's like down the group. It's gonna increase. Fine. So these two stuff are correct. It's going to be increasing acidic character. Fine. So then here you have got like CO2, SiO2, and then SnO2, PbO2, right? So this is actually matched with the oxidizing power. So based on the oxidizing power, we will learn it in the upcoming chapter, oxidation reduction. Okay, we have got like redox reaction where we will learn like something. Got it? So do not want to worry about this oxidizing power as if now, right? Do not want to worry about this one. That, and so here option 2 will be my answer. Let me tell you, here you have got like H2O, H2S, H2Se, H2T. Even if you look over here, it's like oxygen family, and then by the way, it is also in the increasing order. But if you look over here, they have given you like pKa values, right? So pKa actually means this is something, it's a kind of pH that we measure. It's a kind of pH, right? So with the case of pH, we know something that is less than 7 is going to be acidic. Something that's greater than 7 is going to be basic, isn't it? So same kind of intuition you'll have to think over here. So pH and pKa. I'll tell you the relation between those two stuff while doing the equilibrium chapter, as if now pKa is something, a kind of pH that we use it to measure for the acidic nature of the acid, right? If pH value decreases, then it's going to be more acidic, right? If pH value increases, then it's going to be more basic. That's the logic, right? So same thing has to apply over here. If pH is going to be less, if pKa is going to be less, that's going to be more acidic. If pKa value is greater, that's going to be more basic, okay? That's going to be less acidic or more basic, whatever it is. Here, what they have given is increasing pKa value. Increasing acidic strength makes sense because as you move across the period, I mean, like down the group, it should be obvious. It should be obvious that the acidic strength increases. What does it represent? If acidic strength increases, then pH value has to decrease, right? So these two stuff has to be oppositely related. So same thing with the case of pKa. If if pKa value decreases, then acidic strength has to increase. Then what should have been given over here? It should have been like decreasing pKa values. But this is the one that is like incorrectly matched. Therefore, H2O, which is less than H2S, H2AC, H2TE. That's right. If they're given you like decreasing pKa values, therefore it should have been other way around, right? So here it's like increasing order. It's not an increasing order. It should have been a decreasing order, right? Therefore, option 2 is the answer over here, right? Got it? It should have been clear. It should be decreasing order, but they're given you the increasing order. That's not the answer over here. Fine. Do not want to worry about this oxidizing power. Fine. So we will get through this oxidizing power in the upcoming chapters. In the redox reaction, we will learn something that is related to oxidizing power. You will have a chart. Only if you know the chart, I'll be able to match it. Fine. In the situation, with the case of lead, this will have an oxidation state of +4. So this can easily get reduced to +2 oxidation state. So this will have the more oxidizing power to it, right? So this actually is a correct arrangement. Do not want to worry about this oxidizing power as of now, because we haven't learned anything to that one. We have got this question in this chapter because with the first three options you'll get the answer. That's why, right? You should be clear with this question. No doubt should be there. Simple one. Let's move to the next question. This question is also statement based one. Simple question. Identify the wrong statement in the following. I just need to get the wrong statement. Let me read the first option. Amongst isoelectronic species, smaller the positive charge on the cation, smaller is the ionic radius. So this is the wrong one, isn't it? So smaller the positive charge, the ionic radius has to be bigger, right? So more the positive charge, it will shrink. But here they have given you the other way around, right? Smaller the positive charge, more the ionic radius. But they have given first option is in itself is wrong. The answer is like option 1. Let me read rest 3 options. Amongst the isoelectronic species, greater the negative charge on the anion, larger is the ionic radius. Fine. Atomic radius of the element increases as one moves down the first group. Whatever the group, as you move down the group, atomic radius is going to increase. Atomic radius of the elements decreases as one moves across from left to right in the second period. Whatever the period it is, as you move from left to right, atomic radius is going to decrease. That is fine. Okay. This sum is simple one. It has to be clear. Let's move to the next one. This question is also simple one. Let me read it. What is the value of electron gain enthalpy of Na plus? So they are asking us to get the value of electron gain enthalpy of Na plus ion. Okay. If IE1, which means first ionization enthalpy of Na equals 5.1 electron volt. So here I've told you, right, if I have to remove an electron from an atom, I just need to give the work, right? That's why it is going to be positive. What they're asking us to find is electron gain enthalpy of Na plus. So if I have to put one extra electron to this Na plus ion, then what will be the electron gain enthalpy? Obviously, if here I just broke that electron from that atom, if the same electron moves into the atom in the situation, it's going to be ion. If the same electron moves into that ion, it will reach the same amount of energy, right? So whatever energy that I gave to remove it, if this, if that electron goes into the atom, it has to release the same amount of energy, right? Energy can neither be destroyed nor be created. Therefore, whatever energy that I gave, it will release the same energy outside and then it will get bonded into that atom. Fine. So here also they haven't asked us to find the electron gain enthalpy of sodium atom. Here they are asking us to find the electron gain enthalpy of Na plus ion. So it has to be the opposite sign for that of the ionization enthalpy, right? Got it? So here the ionization enthalpy is 5.1 electron volt. If the same electron moves into it, then that has to be positive. Then that has to be negative. So it should give you minus 5.1 EV. Fine. So the answer over here is negative 5.1 EV. There is nothing to solve with the mathematics. Only thing is you just need to flip the sign and you will end up getting the answer. Fine. Simple question. Let's move on to the next one. Next question is also simple one. Which of the following oxides is amphoteric? So if we are thorough with the diagram that I've given you, got it? A basic acidic and then the amphoteric, you'll be able to get this one straight away. So first one, you have got like SnO2, that's gonna be amphoteric because here it's gonna be carbon, silicon. Those two stuff will be acidic. Then you would have got like carbon, silicon, germanium, tin, lead, right? So this is like tin oxide. Therefore, this one should be my answer. So SnO2 is going to be amphoteric. If you just look at the rest option, that will be either basic or acidic. Calcium oxide, it's towards the left, therefore that's going to be basic. SiO2. So here carbon, silicon. Carbon is also acidic, silicon will also be acidic. Therefore 3 and 4 are going to be acidic. This one is basic. SnO2 is the only option. That's going to be amphoteric. Fine. You have to be clear with this question. We can move to the next question, which will be the last question for this session. Fine. This one is also a simple one based on the order of ionic radii. Let me read the question. The correct order of the decreasing ionic radii amongst the following isoelectronic species. So they have given you clearly this is going to be isoelectronic species. So you've got like sulfur, chlorine. Okay, so then you would have got like argon, that's not there. Then comes potassium, calcium. Okay. So this should obviously be an isoelectronic species. Fine. So more the negative will have bigger radius. So S2 minus will have the bigger radius. Then you should have got the chlorine Cl minus. Then you should have got the least positive. That's going to be K plus. Then the more positive, which is calcium 2 plus. Fine. Simple one. These are something that I've already explained to you. The answer here is option 3. Fine. So you should be clear with all sorts of sums that we have seen. We did see sums that were related to acidic strength, increasing, decreasing order, something that's related to the IUPAC convention, fine. So you should be clear with all the stuff that I have taught you in the theory, fine. If you're just thorough and if you have memorized all those stuff, then question will be super easy. Just look at the question, straight away you'll get the answer. So these questions will be like the question that you get in the biology. Just read the question, just look at the option, you'll get the answer. That's it, fine. But you should have clearly learned this chapter properly. Whatever I told you, you should have memorized those stuff. Whatever logic I have told you, you should be clear with those logic. Then these sums will be like easy, right? Fine. So no doubt should be there with all the sums that we have seen. Everything has to be clear. Fine. So with this, the video gets completed. Bye.